Welcome. This is Algebra 2, Unit 2.4. Vertex to standard form is what we're doing in this unit. Vertex is what you've been looking at, the HK format. Standard is, I just think of the standard ABCs. It's ax squared plus bx plus c. Okay? I'm just going to show you how you convert from vertex to standard. Then I'll show you how to go from standard back to vertex, and then we'll look at graphing, whichever way you'd want to do it. So here is a standard equation, a vertex equation. We've got the h and the k here, and the first step in switching it to standard is we take this x minus 4 that's squared. That means x minus 4 times x minus 4, and you go ahead and you FOIL or box it. You would end up with this right here. Then bring down the 2 and the 3 that were on the outside. Now we distribute the 2 to each of those, and we have two like terms here, that 32 plus 3, and that equals 35, and you've converted to standard form. Okay, write that in your notes. You're going to do some. Make sure to write everything so that you know exactly how the steps go, and you can get some help as you're doing that. Now, if we're in standard form and we go to vertex, you need to watch Completing the Square first. Stop this video if you haven't watched Completing the Square, and go to the short little video on completing the square. So here's what we do, is we're building that square out of these pieces right here. Well, that piece isn't there, but we have the x squared plus 6x, so we divide that 6x in half. If you think about the square that you've just seen on that video, you've got 6 pieces here. You take half of them and put them over here to form the square. And then to fill in, you would need 9 little pieces, which is how we get the 9. Or you take the 6, cut it in half, get your answer, and then square it. Now, I always do this here, even though I could do it in my head. Helps me to remember the next step. I see the 3 squared right there, and I just bring it right down here. Then I drop down my x. I don't bring it as x squared because it's being squared out here. And then I drop this sign, so it's x plus 3 squared. Now I just combine these two out here, positive 4 and negative 9. The reason we have negative 9 is we had to keep it equal. When we added a 9 here, we needed to put a minus 9 here so that it didn't change the value. They balanced each other out to being 0. 4 minus 9 is negative 5, and you've just converted this standard into this in the vertex. Okay? Again, write everything down. We can do some together. So now we're given the option to graph this. X squared minus 8x plus 12. 2 different ways you can graph now. If you prefer to graph in vertex form, we'll do that in a second. In standard form, you just take the b value. Here's where your a and b would be. The a is 1, b is negative 8, and c is 12. Okay? So, to graph in standard, you'd go the axis of symmetry, negative b over 2a, negative 8 would be a positive 8 over 2 times 1, positive 8 over 2 times 1 is 2, 8 divided by 2 is 4. Now you would plug that value in. 4 squared is 16. 8 times 4 is 32, so 16 minus 32. And a funny little thing that always happens, these always end up with this one half the size of that one and opposite signs. So when I look at the first two, I always just go with this sign and that number. Plus 12. Negative 16 plus 12 is negative 4. So that's my vertex. 4, negative 4. And now my y-intercept's visible in the standard form. It is 12. So 0, 12. So I come up to 12. And that's where it would cross. This is my axis of symmetry. So I can just go equal number of distance over here. 1, 2, 3, 4. 1, 2, 3, 4. Right there, and now I can connect my points. If I wanted to do that in vertex form, I would have gone x squared minus 8x plus blank plus 12 minus blank. Yeah, I would have taken my 8 divided by 2, would have gotten negative 4. Negative 4 squared is 16 minus 16. Now this all goes into this x minus 4 squared. 12 minus 16 is minus 4. And so that's my vertex, is 4, negative 4. That's exactly what I just got. And now they're set up right there. Okay? So that's how you graph them. Go back to HK or vertex form in graphing if that was a little too fast. Modeling the standard form, we have a path of a golf ball. It's negative 16t squared plus 64t. What I would probably do in graphing that, again, you can just go negative b over 2a to find your axis of symmetry. This is your a, this is your b. Negative b would be a negative 64 over 2 times negative 16. That's going to be a negative 32, negative 64, so it equals positive 2. Okay? Now we have, so that means t is in seconds, so 1 second, 2 seconds, that's the height of our vertex. So we know that in 4 seconds that ball's back down on the ground. The way I know that is 2, the ball starts down here at 0 because my y-intercept's 0, and 2 is the halfway point. That's my axis of symmetry, so 4 has to be when it lands, 4 seconds. Okay, now it says after 1 second, it's 48. So you could come up here and go 48. 1 second, well, we know that it reflects right across that axis of symmetry, so we know that at 3 seconds, it's also at 48. Okay, that would be the easiest way to do it, just by graphing. Okay, we'll see you in class. Bring your questions.